Okay, good morning, good morning. So today, Monday, October 5th, we are going to go through a couple warm-ups here, but we're going to really talk about function notation. So before we talked a little bit about vocab, input, output, domain, range, all those things. Well, today we're going to actually show you what a function really does. So number one, or part of this warm-up here, says use the following equation to complete the following table. They're talking about this table. So as you remember, the x side is our input, okay, and the y side is our output, and we're basically going to get these numbers from this table, okay? So let's go ahead and plug them in. Remember that x is our input, y is our output. So in the first line here, we have -2 is our input. So we're going to plug that in for x and solve, and that'll give us our y value. Okay, so our first y value is -7. Okay, now notice in the second line here, we're given a y value instead, so we got to plug in for y and solve for x. So y is 13, but that's okay, we just work our way backwards. Subtract 3 from both sides, you get 10 equals 5x, divide by 5, divide by 5, and x equals 2, okay? So we have -2 and then 2, 13, all right? And now we have an x again, so we're going to plug in for x. 5 times 5, I think that was, right? Yeah. Plus 3. Okay, so y is 25 plus 3, y is 28. Okay, so as you can see, whether you're given an output or an input, you can work your way backwards and figure out the opposite one that's there. So as you can see, also under function notation, I've already listed out what all of these represent. So the f in function notation, so f of x, we talked about this on Friday a little bit. This is denounced f of x. That's how you say this right here, f of x. It's basically saying this is the name of the function. Sometimes you'll see stuff that says g of x or h of x, okay? So it can change the letter out front, and that just changes the name of the function. But each time it's saying f of x or g of x, okay? X is going to be the input or the domain, right? So this is always from the function. So this is a notation, function notation saying this is a function where x is going to be our input. Okay, so it could also be like you'll see sometimes it'll say h of t. Okay, so h is the name of the function, but t is our input. So it just kind of depends on what variable they want to use. And then lastly here, you'll obviously have your actual equation or your expression on the right side that you'll solve for. Okay, that's the output or your range. It's also called a rule. Okay, so make sure to get those copied down. But that's what it all means. So let's take a look at some examples and go through those together. Use the following. One second, got to plug in my charger here. Use the following information to fill out the table. So f of 2 equals 4. So remember, in function notation, this is our input, this is our output. So if our input was 2, that goes in the table here, and our output is 4. So f of x is saying the same thing as y. Okay, if it says f of x, it's the same thing as y. So now, what's our input, what's our output? Input is 3, our output was 6. Input was 4, output was 8. Input was 5, output was 10. Okay, all right, same thing here. Now look, different letter, but that's okay. It's a different name of the function. Still, input is in the parentheses, output here. So input was 3, output was -4. Input was 4, output was -6. And it continues. So 5, -8, 6, -10. Okay, example 2 says evaluating functions with a graph. Use the graph to identify the following. So this is a graph of g of x. So it's just named g, but the input or the x-axis, right, is the x value. Okay, so this says at g of 0, what is the output? So if this is our input, we're going to go to our graph. Okay, so we're going to go to our graph. It says our input is 0, so x is 0 right here. Okay, what's our y value at 0? Our y value right there is 2. All right, what if our input is 2 on the graph? Okay, so I'm going to go where x is 2, go up to the blue line, okay, and this is 1. So this is about, we'll say 1.5. Okay, what value of x does g of x equal 0? Okay, so now it wants to know what's the input that produces 0 on the output. So if I'm looking at this graph and I'm tracing it, I need to know when does it touch the x-axis, because that's when y is 0. So when does that happen? About right there, which is, let's see, 1, 2, 3, a little over 3, so let's say 3.25. Negative 3.25. Okay, what value of x does g of x equal 5? So again, I'm going to go trace it. I'm looking for 1, 2, 3, 4, 5. Oh, wait a second. Is that graph ever going to touch 5? No. So there is none. Okay, so that would affect our domain and range, right? All right. So let's continue here. Another graph, f of x. So what is the output if the input is 0? Well, here's the x, here's the y. Input of 0 is right here, so it's going to go down from there, and it's going to be right there. So the output would be negative 1. Okay, how about the input of negative 4? 1, 2, 3, 4. Go up is where the blue line is, and that is a positive 1. For what value of x does f of x equal 1? Okay, so if the y value is 1, that's right here. Okay, and if you look, we actually have a couple spots. We have here, 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 and here. So we have 4 values. Let's see, so negative 1, 2, 3, 4, negative 6, negative 8, and 1, 2, 3, 4, 5, 6, 7, positive 8. So negative 8, negative 6, negative 4, and positive 8. Okay, that would be our domain. That would give us that output. All right, evaluating functions with equations, use the following information to evaluate the function. So f of x is this function, h of x is this function, g of x is this function. So depending upon which input they give us, that's the function that we use. So when it says f of 2, we're going to use this one, okay? And we're just going to plug in. So negative 3 times 2 plus 5. That would give us negative 6 plus 5, which is negative 1. Done. How about g of negative 1? Okay, that's up here, right? Because this is the g of x. So this is negative 1 minus 3, which is positive 1 minus 3, which is negative 2. Okay. H of 4, that's this one up here. So this is 1/2. 4 is our input. Minus 4. Half of 4 is 2. 2 minus 4 gives you negative 2. Okay, and then f of negative 3, so negative 3x plus 5, negative 3x, negative x is negative 3 plus 5. This gives us 9 plus 5, which is 14. Done. Okay, then it says solve for x for the following. So if our first function equals negative 10, we need to solve for x. So we're going to say negative 10 is what f of x equals. So we're just basically going to set that equal to the actual function and then solve. This gives us negative 15. Negative 15 equals negative 3x. Divide by negative 3. 5 equals x. Okay. G of x is negative 5. So negative 5 equals, g of x function was negative x minus 3. Okay, so I'm going to add 3 to both sides. Gives me negative 2 equals negative x. Divide by negative 1 to get rid of that negative, and I have 2 equals x. Done. Okay, h of x equals 1. So h of x was 1/2 x minus 4. And that equals 1. So we're going to add 4 to both sides. 1/2 x equals 5. Okay, we're going to multiply then by the reciprocal because we have a fraction out front. That gives us x equals, because these cancel, 5 times 2 is 10. 10 divided by 1 is still just 10. Okay, moving on. Example 4. If g of x equals this and f of x equals this, evaluate the following. So we are going to basically do the operation that it says. So this says the input is negative 1 of g of x. So this is going to be 3 times the 2 and then plugging in 1. So basically we're doing 3 times this, which is really this. Okay, so this is 3 times 1 squared using PEMDAS, by the way. Parentheses first. 1 squared is 1. 1 times 2 is 2. Okay, and minus 4. So this is 3 times negative 2, which is negative 6. Okay, so g of 2 plus f of 3. So 2 times 2 squared minus 4 plus f of 3 is negative x, so this would be negative 3. Okay, so 2 squared is 4. 4 times 2 is, we're going to get rid of that plus sign, minus 3. 2 times 4 is 8. 8 minus 4 is 4. 4 minus 3 is 1. Okay, half of g of 2, so 1/2 of 2 times 2 squared minus 4. So half of 2 squared is 4. 4 times 2 is 8. So half of 4 is 2. Okay, same thing here, negative 2, plugging in 1 for g of x. So this is 2 times 1 squared minus 4 minus 5 times f of 5 is negative 5. Okay, so 1 squared is 1, times 2 is 2. 2 minus 4 is negative 2. This would be a positive 25. Negative 5 times negative 5. So this would be a positive 4 plus a positive 25 gives me 29. Okay, last example here. Function notation in context. So if h of t equals 34t plus 50 represents the height of a hot air balloon after t minutes, okay, what does h of 15 represent? So this is just understanding like what the context means. So again, h is the height of the hot air balloon and t is minutes. So what does h of 15 mean? H of 15 represents the height of the hot air balloon after 15 seconds, right? Time 15 minutes, because it's in minutes. Okay, so that's really all it wanted to know is like, what does it represent? You don't have to solve, it just wants to know what it represents. Could you solve it? Absolutely. We don't need to though. All right, so you have an exit ticket for homework tonight. If you have questions, you can go back, pause, replay this, make sure that you're understanding the context. Send me a Canvas message if you have any questions. Otherwise, I will see you all in class.